là là!
Hi everyone and welcome back to another National 4 maths lesson, and in this lesson we'll be continuing on trigonometry, and we'll just be going over a few more examples to help us practice using problem solving skills involving trigonometry, and also introduce this thing called the inverse functions of the sine, cos and tan, and how we can use this to calculate the angles within a right angled triangle. So in the last lesson we came to the conclusion that we can use these things called trig ratios, which is these three equations here, to either solve the length of a side within a right angled triangle or to calculate an angle within a right angled triangle, obviously other than the right angle itself. And we looked at a few examples in the last lesson covering how we calculate the length of a side using these ratios, but we didn't look at how we can solve an angle, so this is what we are going to do in this lesson. We knew that in order to calculate a length, we need at least one value of a length of a side within the triangle, and also one other known angle other than the right angle. And in this lesson, to calculate an angle within the right angled triangle, we're going to have to know two lengths of the side of a right angled triangle. So let's look at an example. So in this question, we've been asked to calculate the size of angle x, and we've been given a length of 10 metres and 4 metres. And the way we solve this problem for an angle is no different if we wanted to do a length using the trig ratios. So the first step we have to do is to label each one of these three sides with the hypotenuse, the adjacent and the opposite. So let's start with the hypotenuse. We know that the hypotenuse lies opposite the right angle, so that's going to be this side. The opposite lies opposite the known angle, or in this case it's the angle we want to figure out, so this is angle x, so therefore that's going to be the opposite. And the adjacent is the other side that lies next to both the right angle and the known angle. And now our next step is figuring out which ratio we want to use. So what we have to do this time is look at the two sides that we know the values of, and in this case it's the adjacent side and the opposite side, because we know the lengths of 4 metres and 10 metres. We don't have any information on the hypotenuse. And then using SOHCAHTOA, because we have the opposite and the adjacent side, that means it's going to be the TOA, and which means the tan ratio we are going to use to figure out angle x. So to write that out, we can say the tan of x degrees is equal to the opposite side over the adjacent side. And from our diagram, we know that the opposite is 4 and the adjacent is equal to 10. And we can even simplify this for us, because 4 over 10 can also be the same as 2 over 5 if we divide the top number by 2 and then the bottom number by 2. So we can say then the tan of x degrees is equal to 2 over 5. Now before, in order to solve this equation, what we already had the value of the angle, so we could already calculate tan of x just by using our calculators, and then we could rearrange this to solve for one of the other sides. But in this case we already know what both of the sides are, and we have to rearrange this equation to have x degrees. But how do we take x degrees out of this tan of x in order to solve it? We know that to solve an equation, if we're going to change the side of something, we have to change the sign. So in this case, in order to bring this tan thing over to the other side, we have to use what is called the inverse functions, and each one of the sine, cos and the tan functions has its own inverse function. And the way we would write this out is, if we want to solve for x, so we can say that x is equal to the inverse of tan, and then we have our sides 2 over 5. So it's this little thing here, this little minus 1, as if it's almost like to a power. That's how we write the inverse of the function. And if this was the sine function or the cos function, it would be the exact same. We can just take this over to the other side and then put a little minus 1, and that indicates that we're using the inverse function. Now just to show you how we can use this on our calculators to solve it, if I said before, we have these three buttons here, the sine, cos and tan, but if you can look closely above them, we can see in the yellow writing, we can see that sine to the minus 1, cos to the minus 1 and tan to the minus 1, and that indicates the inverse function of each of these. And the way that we can use them in the calculator is as if we press the shift button up the top here, and then after that we can press any one of the sine, cos or tan buttons, and if we do that, if we press the shift and then that button there, that will give us the inverse function needed to solve for an angle. And now if we put this equation into a calculator using the inverse tan button, we can then say that x is equal to a value of roughly 22 degrees. So that means that this angle in here, what the question asks, is equal to 22 degrees. And we did this using what is called the inverse functions. And all we really need to know is if we ever have something like this, like the tan of x, and what we want to solve for is x, all we have to do is move the tan or the cos or the sine over to the other side and it becomes the inverse, and this is how we write it out like this. And then to use this, we put it in our calculators by pressing shift and then the sine, cos or tan button, and then that's how it appears for us like this, and as a result we get the right answer. Okay, so let's have a look at this question now. We have two parts to it, and the first part is asking us to calculate the size of angle x in degrees, which we can see here, that's this angle. And then B, we've also been asked to calculate a length y in metres, which we can see here as well. And we've also been given two lengths of the right angled triangle of 3 metres and 7.5 metres. So let's get started with part A. It begins the same as always. First we label the sides of the right angled triangle. So here we have an hypotenuse of 7.5 metres and an adjacent of 3 metres, and because these are the two known lengths, then we can say that the ratio that we have to use is the cosine, the ca, because here we have the adjacent and the hypotenuse values. So we can write that out as the cosine or the cos of x is equal to the adjacent side over the hypotenuse, and that is equal to 3 metres divided by 7.5 metres. And then so if we have the cosine of x is equal to 3 divided by 7.5, what do we need to do? Well, we need to solve for x, and that means taking the cosine over to the other side and taking the inverse value of this. So we can write that as x is equal to the inverse cos of 3 divided by 7.5. And if we put this into our calculators, we get a value of roughly x is equal to 66 degrees. So now we can say this angle is equal to 66 degrees, and that is part 1 complete. Now to solve for this length, there's actually two ways we can go about it. Because it's a right angled triangle and we already know the length of two other sides, we can therefore use Pythagoras to solve for the other length. Or we can also use trig ratios again, because we can pick one side and the angle, and doing that we can also solve for y. So what I'm going to do, I'm going to go over two methods, and just to show that both of them work and will give us the same answer. So let's begin with Pythagoras. We know that Pythagoras' theorem for a right angled triangle, we can say that a squared is equal to b squared plus c squared, with a being the hypotenuse and b and c being the other two sides. And from our diagram we know that the hypotenuse is 7.5 and b and c are the other two sides, so we can just say b is equal to this one, 3 metres, and c is equal to y. So let's write that out. We can say that 7.5 squared is equal to 3 squared plus y squared. And because we want to solve for y, then we have to rearrange this equation and move this 3 squared over to the other side. And because it's on this side and it's positive, we move it over to this side and it becomes negative, or take away 3 squared. So beginning with y squared on the left hand side now, we can say that y squared is equal to 7.5 squared, take away 3 squared. And if we use our calculators, we can say that 7.5 squared is equal to 56.25, and that's take away 3 squared, which is 9, and taking that away, that gives us a value of 47.25. And then we know that in order to get y, we have to take the square root of 47.25. And again, if we put that into our calculators, the square root of 47.25, that gives us a value of approximately 6.8 6.87 metres. So that's us solved the length of this side using Pythagoras, but now we're going to try and get the exact same answer using method 2 of trigonometry. So since we already have the sides labelled, the next step is to figure out which of the ratios that we're going to use. And in this case we actually have a choice because we already have two sides and one angle, therefore we can pick whatever ratio we want to use. So I'm going to, because we want to figure out y, it has to be the opposite, and out of the hypotenuse and the adjacent, I'm just going to pick the adjacent because 3 metres is a whole number and it's easier to work with rather than 7.5. So if we're using the opposite and the adjacent, that means that we're going to be using the tan ratio or the TOA. So we can say that the tan of x degrees is equal to the opposite side over the adjacent, and we have the angle now of 66 degrees, and the opposite side is y, which we want to figure out, and the adjacent side is 3. And then what we can say then is, rearranging for y, we can bring this 3 metres over to the other side and multiply it by this because it's dividing on this side. So we can say then that y is equal to 3 multiplied by the tan of 66 degrees, and we get an answer then of 6.74 metres. So if you notice that for method 1 using Pythagoras and method 2, we got slightly different answers. They're close enough, but they weren't exactly the same. Now, why do you think this is? Simple answer is due to rounding and using our calculators to solve. When we calculated the value of 66 degrees in our calculator, you would notice that there were many other numbers after the decimal point, and because we forgot about the numbers and just took 66 as a whole number, this has led to the difference in these two answers. But let's say for example we put two other numbers after the decimal point. We can see that doing this makes our answer much more accurate, and in fact when we do this we get the exact same answer as if we were to solve using Pythagoras a value of 6.87 metres. The reason I just wanted to include this in was that when we use the calculators and we use things like decimal places and rounding numbers, this can have an impact on our final answer, and therefore when we normally write the answer of a question, we often have to write how much we have rounded it by, or how much we have sort of took away the numbers after the decimal point on the calculator. But as we can see here, there isn't even much of a difference between the two values of using decimal places and not, but it's just something to bear in mind when working with trig ratios and trigonometry in general, because oftentimes when you put values into a calculator using this, you'll find out that you have lots and lots of numbers after the decimal point. So it's just something to bear in mind and keep your eye on when solving problems, and to know that if you ever come across any difference like this, it's often due to this sort of rounding and numbers after the decimal point. So let's just recap some of the main things that we've learned in this lesson. So the key takeaway is, if we want to solve an angle using trig ratios and we have two sides of a right angled triangle, what we need to do is, number 1, pick what ratio we're going to use, and then after that we use the inverse function of whatever ratio that we've chosen in order to solve for angle x. And remember, be careful when solving the equations. Remember, if we're going to change the side of one of the things within the equation, we have to change the sign as well in order to solve whatever we want to solve for. And some of the rules are, if it's positive or being added on one side, it's going to be negative or taken away on the other side. If it's multiplying on one side, we take it over to the other side and it becomes a division. And we now know that for our 3 trig ratios, if it's the sine of x, the cos of x, or the tan of x on one side, what we can do is take the inverse of each one of these and move it over to the other side, and then finish our equation off from there. So I hope this video has been helpful to you, and if that's been the case, please give us a like to show the channel support. And as always, if you have any questions on this video or any other topics, make sure to ask us down below, or you can visit penguin-learning.com. Thanks again for watching this National 4 Maths lesson, and I'll see you in the next video.